Okay, this is the last lesson of the year, 12.3b. Go ahead and write down this formula here for t. B is the slope of the sample. The hypothesized slope we also call beta, Greek letter for the population slope. And SE of B means the standard error of the slope. Again, B is slope. This test is all about slope. So the last lesson we learned about intervals for slope. These are t-tests for slope. New on this one, just like it was in the last one, I guess, degrees of freedom is n-2. Usually it's n-1, so this is unusual. I have a worksheet for this, but this is the situation. Infants who cry easily may be more easily stimulated than others, and may be a sign of higher IQ. So maybe if you cry a lot as a baby, you might have a really high IQ. They actually studied this. So they did research. Research explores this idea. They took between crying infants 4 to 10 days old and their later IQ scores. A snap of a rubber band on the sole of their foot caused the infants to cry. The researchers recorded the crying and measures its intensity over a 20-second period. They later measured the child's IQ at age 3, and here's the data. They sampled 38 students here. As is usual here, they're giving us 3 different data dump graphs, all this information. And it says, here's the computer output at the 5% level. Is there convincing evidence of a positive linear relationship between count of crying peaks and the IQ? So that's the key that this is a slope test here, because it's talking about slope, positive linear relationship, that's slope, right? So you're gonna look at the answers and try to figure it out. So let's go through the sheet and think about what we need to do first. So the first thing we do is the null and the alternate, right? So for this one, the null is nothing going on, right? There's no relationship between how much you cry as a baby and your IQ. It's silly, right? So there's no relationship. So because it's all about slope, you would actually say beta is equal to 0 is your null. The slope is 0. There's no positive or negative relationship. The alternate is, because of the direction it gives here, that beta is bigger than 0. So we would say it is bigger than 0. Define the parameter, in this case, beta, which is the hypothesized slope of the population regression line. That's what that is. And then X and Y are down here in the figure. X is the count of crying peaks, and Y is the IQ measured at 3 years old. And so those are the first answers there. And don't forget to put the alpha level. I think on your sheet I put significance level, but it's called the alpha level or significance level, I guess. Okay, so next step, liner. So if you remember, LINER is the acronym remembering the conditions for slope tests or intervals. So L stands for linear. Look at the first graph. Does that graph look linear? Sure, passes the eye test. Is the residual plot scattered? That confirms that it is in fact linear, and it does look scattered, so it is a good linear fit. I stands for independent. You want to check the less than 10% condition. 38, that's how many babies were sampled, is less than 10% of all babies. N stands for approximately normal or normal. And you don't have to use the word normal. You have to say no major skew, no outliers here, and it does look approximately normal, roughly. Liner, so E stands for equal standard deviation. Look above the residual line, equals 0, and below, is it somewhat equally spread below and above? It is, so it passes that test. And finally, R stands for random. It was a random sample of 38 babies, so it passes that test. Okay, the do section is kind of funny. It's not that much that you're going to need to show. So for the do section, you're going to show stuff like, okay, so you want to do degrees of freedom, so you don't need this, equals 38 minus 2, which is 36. Put the t value. So if you look at this one, the y-intercept is 91. 0.268. The slope is 1.49. It's important you recognize the slope. So if you look at that second row, all those numbers to the right of the slope are talking about the slope. All the numbers to the right of the y-intercept are talking about the y-intercept. So the next number would be the standard error of the slope, 0.487. T is 3.07, and it gives you the p-value, which we'll talk about in a second. So T is 3.07. Now you're going to be tempted to write p-value and write 0.004, but if you were one thing, so if this is a one-sided test, it's a big if, but if it's a one-sided test, you have to divide the stated p-value by 2. So in other words, you would say 0.004 divided by 2 is our p-value of 0.002. Because this is one-sided test, if you remember, beta was greater than 0, so one-sided test. So you have to divide the stated p-value by 2 to get 0.002. That's it. That's all you need for your do section. Pretty amazing, right? The other way you could have caught yourself, because let's say you forget to divide that one by 2. I'm just mentioning this. So if you drew, kind of roughly drew this, you got 1, you got 2, you got 3. 3.07 somewhere over here shaded this way, so that's the t value of 3.07. So if you get your calculator out and go menu 6, 5, and go to TCDF. So your lower bound is 3.07, I believe. Upper bound infinity. Degrees of freedom, I think, was 36. So you get 0.02. So you get the correct p-value. Again, that's 0.004 divided by 2. If you did see TCDF, it's a way to double check your work. I just want you to know that. Because our p-value is 0.002 and our alpha level, which is less than the alpha level of 5%, we do reject the null. We do have evidence to say there is a relationship between crying when you're an infant and the IQ you have later on in life. So kind of interesting. I wouldn't have thought that, but it's true. This is what they said for these guys. Good. Try this one. Try to work this as much as you can without looking at your notes to go through all the steps. This is the situation. Do customers who stay longer at buffets give larger tips? Charlotte, an APSTAT student who worked at an Asian-style buffet, decided to investigate this question for a second semester project. During her job as hostess, she obtained a random sample of receipts, which included length of time in minutes, a party stayed, how long they stayed, and the tip amount in dollars. Here's the data. So you see the data there. Here's the computer output. Do the data provide convincing evidence of a positive linear relationship between the amount of time and the amount of tip customers leave? So I would stop the video and do this one. I'm just going to go through the answers with you. Again, similar to last one, we want a positive relationship, linear relationship. So beta has to be greater than 0. Define beta. Check the conditions. The graph looks linear. The residual plot shows scatter. Independent, 12 is less than 10% of all the receipts. Normal, now notice they didn't say normal, and this graph is not normal if you look at it, but somewhat symmetric, no major skew, and no outliers, no apparent outliers. That's okay. If you look at the residual plot above and below the line, it looks somewhat equal standard deviation. And then a random sample of 12 receipts. And finally, the do section, which is not much. You did have to divide by 2 because it's one-sided. I also put the degrees of freedom, which is the number of, looks like there were 12 receipts. So 12 minus 2 is 10 would be the degrees of freedom. And because our p-value is 12%, which is greater than alpha, we fail to reject. There's not evidence to say that that works. If you wanted to know how to do this in your calculator, it's a linear regression t-test, but you probably won't have to do that for most of these questions. They're going to give you the data.